So before we start our data collection, let's take a moment to look at the tools we're going to use and talk about how each one of those tools is going to provide us with a specific data point. So the first tool that we want to look at is a standard measuring tape. And this is we're going to use for one of our techniques for collecting data, which is called the transect method. And in this particular case, we're going to straddle the border of both our open field and our forest, and we're going to measure a fixed distance both in the forest and then measure that same fixed distance in the open field. And we're going to see how we're going to take certain intervals within that distance in order to do things like look at the number of species within each of those intervals, look at the type of light that's coming in within each of those intervals, and look at things like soil fertility. The other technique we're going to use is using our quadrant. Now, the quadrant is its own self-contained area. And so what we're going to do is you're going to see how we're going to randomly throw the quadrant both in our open field and in our forest area for 3 to 4 repetitions. And then within that quadrant, we're going to take our measurements. So all the measurements will be happening in the quadrant. Both of these techniques are ways in which we can be sure that we are gathering data consistently both for our open field and our forest so that it is comparable data. Our next set of tools are going to be the actual tools that will allow us to generate our data. And so one set we have is our thermometer. And so we may want to do things like measure the temperature of the soil. And when we measure the temperature of the soil, we often are looking at the different layers of the soil. So we may decide to take the first ½ inch, measure the temperature, and then measure the temperature of the next inch, and then the next 1.5 inches, and then the next 2 inches. So we're looking at how the temperature changes as we move further down in the soil. The other thing we're going to look at is a multi-purpose tool, and this tool will allow us to measure things like our soil fertility, our pH, and things like the amount of light that's reaching the soil itself. Now you may ask yourself, why do we care about those things? Well, when we start comparing the species diversity in the open field to that in the forest, we want to look at what aspects in our ecosystem is contributing to the differences we see in that species diversity. And so it may be the amount of light, which it may impact the type of plants that are going to grow in that ecosystem. It may be fertility. So as we look at the forest, we'll look at what type of dendritic material we have. And that is dead stuff that falls to the soil itself. That contributes to the fertility versus do we have the same type of dendritic material in our open field. When we're looking at pH, pH often can impact the type of plant species that is capable of growing in that soil. And so we want to see if there's a difference in pH. These tools are going to allow us to see what is contributing to the difference between the species we find in our open field and the species we find in our forest. All right, so let's first do our quadrant method. And so in the quadrant method, we're going to randomly throw our quadrant in both our open field and our forest. And once the quadrant settles, we're then going to move tools to that area, and then we're going to start to get our data. So let's do our first data sample, and that is we're going to core the soil. So as you see, the student is removing a core sample of the soil, and this is allowing her to analyze the moisture in the soil. So as she is beginning to dig more into the soil, I want you to pay close attention to the different color that you see as we move further down in the soil. The darker soil tells me that there is more decayed material in that layer versus the lighter soil. You can also see with the darker soil that we have a slightly higher moisture content than as we move further down into the soil. We're going to compare this when we do the forest to see if we see that same type of soil profile. Okay? The other thing we're going to do is, now that we've created a hole in our core, we're now going to take our thermometer and we just want to temp the soil. We want to see if temperature is going to have any impact on the species diversity, and so we're going to temp both the open field soil and the forest soil. Our expectations. We may assume that because the open field is getting more sunlight, that we may find a higher temperature in the soil versus in our forest. But we don't know yet, and this is the beauty of science. Sometimes our assumptions don't exactly mesh up with the data, and so we're going to see what the data is going to tell us. So now that we have measured our soil core sample and we've gotten our temperature of the soil, next we want to measure pH and the amount of light that's entering our quadrant. And so first you'll see that using our multi-device, we have it on pH now, and so we're going to look at what pH is being registered. Now we want to go ahead and switch it so that we can look at the light intensity that's being measured in our quadrant. So now that we have the data that we're looking for, we then would take our quadrant and we would randomly throw it in another area of the open field. And we would repeat that for 4 repetitions so that we get good quality data, and we can also account for any variation we're going to see in the data itself. Remember that we are dealing with biological systems, and so biological systems have natural variation, and we want to try to account for that variation as much as possible because it may impact the decision we make about the management of our ecosystem. So now we're going to take that same technique and the same type of measurements, and we're going to do it in the forest environment.